for the first one, I took out the x from the numerator.
Okay,
So
you factor out.
Yeah, I factored it out. So that would turn into x parentheses x minus 4. And then in the denominator, I also factored it out. And that would turn into x minus 4, x plus 1.
Mm-hmm.
And then since they have a thing in common, x minus 4, both the numerator and the denominator. So I canceled that out and it turned into x over x plus 1. And then I just substitute the 4 into the x and I got 4 over 5.
Okay, great. Yes, thank you.
You're welcome.
Thank you. Okay. Tanzania is not here, right? Tanzania, are you here? If not, Mark, Raphael, are you here?
Yeah.
Okay. Can you show us, good morning, can you show us the next one?
Number 16?
Right.
Yeah, sure.
Thank you.
So, number 16. You want me to do step by step, correct?
Yes, please.
All right. So we're told to evaluate the limit, but as usual, you can't do it in the denominator because it will be undefined. So we have to factor out x equals -1. So what we have to do is factor both the numerator and the denominator. So how we do that, we do, the double bubble method. Pretty sure we will. Do you want me to keep going?
Yeah, how would you factor them out?
So what I did for the numerator, I found that it's 2x plus 1, open parentheses, close parentheses, open parentheses, x plus 1, close parentheses. So then we have two.
Good.
And then we have, on the denominator, we have x minus 3 as one factor and x plus 1 as one factor. So we could cancel out the x plus 1 because that would equal to 1. So then we're left with 2x plus 1 over x minus 3. So then what we could do is now solve for the limit. And so since it's kind of continuous at this point, by definition, we could just plug it in or evaluate it. So, you plug in 1/4 for x, and you get 1 over 4. Or you get -1. You plug in -1 for x, my bad, and you get 1 over 4.
Okay. Yeah, nice. Thank you. Let me see next one. This is IRSA. Elsa, are you here? Okay, Alexandra?
That's me.
Oh, thank you.
Number
Alexandra, the next one.
Number 18.
Number 18. Yes, please.
Okay. So, what I did was, well, you have 2 plus h to the 3 minus 8 over h. So then I actually multiplied out 2 plus h, and I ended up with h cubed plus 6h squared plus 12h. And then so I divided that by h, and I believe I already subtracted minus 8. And then I ended up with h squared plus 6h plus 12. And at that point, I substituted 0, and I got that the limit as h approaches 0 is equal to 12.
Okay, all right. Thank you.
Mm-hmm.
Emily? Emily, are you here? Jason? Jason? This is Andrew, Denise.
Yes.
Oh, okay. Would you please show next one?
Number 20.
Well, you could show 20 or 22.
Oh, 22.
Okay.
Okay. So first, I multiplied the it by its conjugate, was square root of 4u plus 1 plus 3. I multiplied the numerator and denominator by that.
Right.
And then I get 4u plus 1 over 9 over u minus 2 times radical 4u plus 1 plus 3. Then I multiply that to 4u minus 8 over u minus 2 times radical 4u plus 1 plus 3. Then I factor the numerator by 4. Then I get 4u minus 2, and then I cancel that to u minus 2 from the numerator to the denominator. Then I get 4 over radical 4u plus 1 plus 3. And then I substituted 2 for u. Then I get 4 over 6, which simplifies to 2 over 3.
Great. Yeah. Okay, thank you.
You're welcome.
Okay, this is Katie. Katie, are you here? Stanley. Stanley Christopher. Okay, this is Noella, Noila.
Good morning, Professor. It's
Good
Nola.
morning, Nola. Nola. Yeah.
Yes, yes. Do you have to go over number 24?
Yes, please.
So given that both the fractions have different denominators, I wanted to factor out the denominator of the second one so that I can multiply the other fraction by t plus 1, thus having a common denominator, which results in t plus 1 over t plus 1 times t plus 1 minus 1 over t times t plus 1. And then we would be able to combine them, which results in t over t times t plus 1. And from there on, we can get t over t times t plus 1. And from there, we can substitute 0, which is the value that t is approaching. And we have a result of 1.
Great. Yeah. Okay, anybody has any question? Let me see. Oh, George is having connection problem. Oh, okay, Tasnia. Tasnia, are you here now? Okay, can you show us the next one? Because when I call you, if so this is a general rule, okay? Sometimes I call people to answer questions. When the person is not there, so I mark absent, all right? So make sure Make sure you answer me.
Professor?
Yes.
I didn't get up to 26 yet.
Oh, okay, then let me see. Let's go back. What about 14? Can you do 14?
14?
Right.
You would have to factor it out first. So the top would be x minus 2x, and then again x minus 2x. And then the bottom would be x plus 2. No. Yeah, x minus 2 and then x minus 1.
No, then you have 1 times 2. That won't give you 4.
Oh, you're right.
Right, your 2 factors. You see, the top you have x minus 4. Maybe you think one of the factors to be x minus 4.
So x plus 4, x minus 1.
No, the opposite. X minus 4, x plus 1. Because the middle one is negative 3x. Because negative 4 plus 1 give you negative 3, right?
Yes.
Okay. Yeah, you may keep going, finish this. Hello? Yeah, the connection is not good. All right. Julie, you're ready for 26? Go ahead.
Okay, so for number 26, what you have to do first is multiply the conjugate. So it would be, it's going to be square root of x squared plus 9 plus 5 by both the numerator and the denominator. And then once you simplify that out, you would get x minus 4 in the top over radical x squared plus 9 and then plus 5. And so then you could substitute in the negative 4 and you would get negative 4 over 5.
Great. Okay, thank you. So last one. Okay, let me try one more time. So Irasa, IRSA, Emily, Jason, Stanley, Christopher, Katie. Okay, Karen.
Hi.
Yes, Karen.
Okay.
Okay, sure. Yeah.
So what I think I did is for the top, I tried to even the denominator, so you multiply that and you should get x squared minus x plus h squared over x squared times x plus h squared over h. And then you should multiply top and bottom by the denominator of the numerator, and that should get you x squared minus x plus h squared over x squared times x plus h squared h. And then I think wait, I'm trying to decode my work, I don't remember. And then, oh yeah, I factored the numerator, which should be x minus x plus h times x plus h over hx squared times h plus x squared. And then that should get you negative h times 2x plus h over hx squared times x plus h squared, and then cancel out the h's, get negative 2x plus h over x squared, x plus h squared. That should simplify to negative 2x over x squared times x squared, so 2x over x to the fourth, and then that should equal to negative 2 over x squared. And then substitute Oh, it's h over h20. So yeah, I think that should be it.
Okay, all right, thank you. Okay, anybody has any questions regarding homework or the material we covered last class? Yes.
This is George. I just have one question.
Yeah.
For number 26 and in general number 22, and whenever you have a square root in the numerator, are you
Right.
just the rule of thumb is to multiply it by its conjugate right away to get rid of it?
No, let's see why we do that.
Can
Right.
you
If
help
we
me
want to get
explain that
rid
to
of
me?
it,
Thank you. Yeah.
yes.
Go ahead.
If we want to get rid of it, yes, that's the trick. But let's see 26, why we want to multiply by its conjugate. Because we want to find the limit when x approaches to -4. So -4 plus 4 will cause the denominator to be 0.
Oh, okay.
Right, so that's a trick. That's why we want to say, okay, let's, one thing we could do is multiply by its conjugate, so I don't have to deal with the square root anymore.
Okay.
Okay, all right. Any other questions? Okay, so I'll keep doing this. All right, for each class, I'll try to leave some exercise for you, and it's like an extra work, a little bit of extra work. So one way is to review for the material we have covered. Another way is to just wait for more students to come into classroom. All right, anybody has any question? So we are in the world of limits right now, right? So this is how we find the limits. So we have done those questions to review that. If you think you can do those kind of questions, you'll be fine for the exams, all right? But if you think you still have to struggle, with those questions, make sure you can solve those kind of questions. Make sure you understand the idea of limit. Okay, now we're going to review for another identity. Remember, we have identity when x approaches 0, the limit of sine x over x is 1. So I'm going to use this prop to try some questions. So on your own, try 49. And also I'm going to call some people, all right, to show us. 51, 53, 50. You know what? Why don't we do all of them? All right. So let's try those 6 questions on your own. Then I'll call on people. While you're doing that, I'm going to check attendance. All right. So some names are not on the list. Maikel, Maikel. Zara, Katie, Victoria.
I'm here.
Oh, I don't see you on the list. All right, thank you. Oh, yes, here, sorry. Raymond, Raymond, thank you. I'm sorry, I'm not able to pronounce your name. Uh, this is HNIN, a middle name OO, last name LWIN.
I'm here.
Oh, okay, thank you. How do I see your name?
Hanan?
Hanan, okay, Hanan, thank you. Carlos,
Yeah, here.
okay, thank you. Oh, sure. Yeah, but finish everything, all right? Try to do every question, because this surely will be on exam. Try to do every question, then we'll show. Um, Oh, not yet. Not yet. Yeah, don't worry about it. You focus on the work, all right? Because I'm just checking who's here and to match with. If I cannot find someone's name on the list, on the attendees, I'll call the name. If your name, for most of you, your name already on the attendees, so I don't have to call you. Victor. Anna. Victor, Anna. Okay, Labiba, Labiba. Hillary. Ryan, Nicholas. Okay, this Mohara, Mokhira. Yang Rui. All right. Okay, I'm going to, so I have volunteers. Let's see. Anybody volunteer for 49?
I'll do 49.
Okay, go ahead. 49.
Just cross, so the answer is 3.
The answer is 3.
Because
Okay,
sin
tell
of
us
x
why.
over x is 1, which gives us 3 and 3 times. And then that will be the answer. First, it will be
Okay,
like 3 sin x over x, and then sin x over x is 1. So 1 times 1, 3.
okay, good. So Elsa is saying The
Professor?
angle is a 3x. Yes.
Sine x over x is 1. Sine x over x is 1 is the that's like established, correct? That's why we use that?
Yes, that's the identity. When x
Alright.
approaches to 0.
Okay.
Okay. So in this case, x is a 3x. So the angle is a 3x. So we want to match up with 3x. That means we need to do sine 3x over 3x. So missing 3 in the denominator. So we multiply by 1. And this one is 3 over 3. Right? So 3 sine 3x over 3x. Then sine 3x over 3x be 1 under the limit when x approaches 0. So we're left with a 3. And the 3 is just a number, right? A limit of a number is a number. So that's 3. Okay, great. So that's 49. I think someone wants to do 50. Julia wants to do 50, right?
Yeah, me.
Yeah, go ahead.
So my answer was for 50 was 2.3. So what I did was I multiplied both the numerator and denominator by 4 times 6x. And so when you multiply it out, you get 4 over 6 times sine 4x over 4x multiplied by 6x over sine 6x. And then once you divide the last two fractions, you get 4 over 6 times 1, and 6x over sine 6x is 1 to the negative 1 power, and when you multiply that, you get 2.3.
2.3. 6 over 4, right?
No,
6 over 4, 2.3.
The answer?
Right.
I mean, yeah.
Right. Because, okay, so we need sine 4x over 4x. We don't have 4x, so we multiply 4x over 4x. So numerator, we have a 4x. Oh, 4 over 6. 4 over 6, isn't it? Or 2 over 3. Right?
I don't know. I don't know the fraction. I got 2.3.
No, 2.3, of course, is
But
not 2.
I ended up
You mean 2
multiplying
over 3?
2 over 6.
I'm sorry?
When I multiplied, I got 4 over 6, and then when I multiplied it out, the answer was 2.3.
Okay, what's 4 over 6?
After you multiply 4...
No, I understand. But what's the simplified version of 4 over 6?
Oh, yeah, 2 over 3.
2 over 3, right? It's not 2.3. You probably misread your
No,
own writing.
the answer, my answer was 2.3, but I multiplied by 2 over 3.
I'm totally confused. What do you mean you multiply by 2 over 3?
So after you multiply the original fraction, sine 4x over sine 6x, by 4 times 6x, both numerator and denominator, you get 4 over 6 times sine 4x over 4x times 6x over sine 6x.
Okay, then?
Yeah, and then when you simplify it, you get, well, if you fully simplify it, it's 2 over 3 times 1 to the negative 1 power.
Okay.
And then when you multiply all of those, you get 2.3.
Can you show us your work?
I don't really know how I would... Yeah, I can write it in the chat if you give me a minute.
Yeah, okay, write on the chat. Because the answer should be 2 over 3. Well, Amir is asking a question, but let's see. I don't have space to write all the steps. You see, for this to work, we need to sine 4x over 4x, right? Which we do not have over 4x. So we multiply by 1. This one is 4x over 4x. Sine 4x over 4x under the limit when x approaches 0 will be 1. So that left us 4x in the numerator. The same thing for the denominator, sine 6x. Remember the identity is saying limit when x approaches 0, sine x over x can be raised by any power. So which means the inverse also equals to 1. So we need 6x in the numerator. We need 6x over sine 6x. So we multiply by 1 again. This one is 6x over 6x. Then we have 6x. Then 6x over sine 6x, under the limit x approaches 0 becomes 1. So we have 6x in the denominator. Then x divided by x equals 1, so we're left with 4 over 6. Or 4 over 6 can be simplified to be 2 over 3. Okay, let's see Julia's answer.
Yeah, that's my fault. I don't know how I got 2.3. It is 2 over 3. I think I just miswrote it.
Right,
Yeah,
right. That's what I was saying. You had your own writing, right? So you have 2 over 3 times 1 raised by negative 1. That's just 2 over 3. Okay, great. All right, next one. Let me see. Next one. Thank you. Katie, are you here? Katie? Okay. Okay, Carlos.
Hi, yeah.
Okay, Carlos, can you try the next one? Thank you.
Yes, so the answer will be 3.
Okay.
I kind of remember using the L'Hopital's rule. So I had the tan 6x and the sine 2x became sec square parentheses 6s c6 times 6 divided by cosine 2x times 2. Excuse me, and that will give me 3 over cosine square cosine square 6s cos 2x, and that will lead to 3 divided over cosine square 6 times 0 cosine 2 times 0.
Hold on 1 second. So if you use the L'Hopital's rule, I didn't talk about L'Hopital's rule. If you use the L'Hopital's rule, what is the derivative of tangent 6t?
Tangent 16?
Right, tan 6t.
16 or 6?
6t, right? This is 6t.
Oh, 6t, I heard 6. Sorry.
Right.
I don't remember. I was actually getting it from I took pre-calc and he kind of went over it.
But right, because if you use L'Hopital's rule is saying you have an indeterminate forms, right? You have 0 over 0.
Or infinite over infinite condition, is that what it is?
Right, or infinity over infinity, then you have to take derivative of both. But let's try not to do that. Let's try to use the identity because we have t approaches 0. Let's try to use identity. Do you know the identity?
Oh,
Sine
sorry, I'm
t.
so used to that I replace the t's to make my life easier all the time.
Oh, x, that's okay. You can use 6x, right?
Yeah, and instead of using, I don't know,
but let's try to use the identity. The identity is the...
Yeah, sorry, it just went off my mind. I was doing it from my notebook. Yeah, so it will be 3 and 1 times 1, obviously 1. 3 divided by 1 will be 3.
Okay, so tangent 60 is sine 60 over cosine 60. So we need to manufacture 60 on the in the denominator. Let me type in here. Okay. So sine 60 over cosine 60. Then divided by sine 2t. We can write them together. There's 3 layers of a fraction. You just multiply the 2 denominators together. And this one, let's look this one. So once we change this tangent 60 to be sine 60 over cosine 60, we have this. So we need 60 in the denominator to use the identity. We need a 60 in the denominator, and we need 2t in the numerator. The 2t over sine 2t becomes 1 under the limit when x approaches 0. And the sine 60 over 60 becomes 1 with the limit at t approaches 0. So we have to multiply by 1, right? This 1, we have to multiply 2 ones. One is 2t over 2t, other one is 60 over 60. So what's left? So we have 60 over 2t cosine 60. T and t cancel out, and cosine 0 is 1, so have 3. That's what you did? Okay, anyone has any question? Okay, next one, VAN.
What am I doing?
VAN. Can you show the next one?
Yes. 52. So it's cosine theta minus 1 over sine theta. So I just separated the numerator from the denominator, and I kind of didn't know what to do at this point, really.
Okay, so what do you think we could do? So we want to find the limit of this, right? One way we have identity to use.
Can you repeat that?
Well, another way, like you said, okay, you want to separate them. If you separate them, can I help you?
Well, I know that cosine x.
That's okay. Let's try next one.
Next one?
No, not you. Not you. I'm going to call somebody else to show this. Karishima. Karishma. Karishima. Okay. All right, that's fine. Okay, Victoria wants to show 52. Go ahead, Victoria.
Yeah, for 52, I multiply both the numerator and the denominator by cosine theta plus 1.
Right.
And for the numerator, I got cosine squared theta minus 1 over sine theta x times cosine theta plus 1. So
Right.
the numerator is identity, so cosine theta squared theta minus 1 is equal to negative sine squared theta. And then you could eliminate the sine theta from numerator and the denominator, which gives you negative sine theta over cosine theta plus 1. And then after you substitute theta as 0, you get negative 0 over 2, which gives you 0.
Great.
Professor, can you go over that one more time, please, if you can?
Okay, so basically, Victoria is using this identity. The identity is saying sine square of an angle plus cosine square of the angle equals to 1. Right? In between of cosine and sine, we want to play this. So that means we want to multiply by its conjugate in this way. So we want to multiply cosine theta. I cannot type in theta, so I'm going to miss theta plus 1 over itself. Right? We multiply by 1. And this one is cosine theta plus 1 over cosine theta plus 1. By doing that, what's cosine? So we get a cosine square theta minus 1. Cosine square theta minus 1. What's that? By this identity down here, that's negative sine square. Right? Cosine theta minus 1 times cosine theta plus 1. The conjugation with each other, that's the difference of two squares. That's cosine square minus 1. By the identity of this, equals a negative sine square. Negative sine theta square. So sine square cancel one term with sine theta here. So the denominator becomes cosine theta plus 1. The numerator will have negative sine theta. The denominator will have cosine theta plus 1. Well, cosine 0 is 1. So we'll have 1 plus 1, the denominator becomes 2. But sine 0 is still 0. So we have 0 divided by 2, that's still 0. Does that make sense?
Yeah, it's clearer a little bit.
Okay. So basically you use identity, right? So you have, maybe let me read one more step. So after simplification, we have negative sine over cosine plus 1. Then the denominator does not cause 0 when we plug in theta to be 0 anymore. So that becomes 0 divided by 2, which is just 0. All right, make sure you can do these kind of questions. Okay, this is typical limit questions. So Vaughn and Karishima, does that make sense for you guys? If you still have question, ask. All right, I can explain more. All right, let's see next one.
Professor?
Yes.
Can you explain 51 again?
51 again, 51. 51. Okay, 51 is red. So tangent we can write as a sine over cosine, right? Is that true?
Yes.
So that means that tangent 6t you can write as sine 6t over cosine 6t.
Okay.
Then divided by sine 2t again, we can just write together. Right, when we have 3 layers of fraction,
Okay.
because you can write the 2 denominators together, right? So sine 6t over
Yes.
cosine 6t sine 2t. So we want to use identity. That means we want to manufacture 6t in the denominator, 2t in the numerator.
Okay.
Right? In that case, we have sine 6t over 6t for the limit t approaches 0 to becomes 1. So we need sine 6t over 6t. We need a 2t over sine 2t. Does that make sense?
Yes.
Okay, but we have to multiply by 1. We have to multiply 2t over 2t, 6t over 6t, right?
Yes.
So that means we're left with 6t over 2t separate this. So then we're left with identity 2 becomes 1. We have 6t over 2t cosine 6t. Now we can plug in 0, right? Cosine 0 is 1, and t over t becomes 1. So 6 over 2, that's 3.
Okay.
All right. Anybody else has any question? Okay. Khizr. I don't know how to pronounce your name. I'm sorry. Khizr. I saw your name.
I'm here, sorry.
Oh, how do I see your name?
It's Khizr.
Khizr. Okay, Khizr. Khizr,
So,
can you show us the next one? Yeah.
I multiplied by 3x to simple, and then I split up the limit. So I got 3 sine 3x over 3x times 1 over 5x cubed minus 4x. And then I simplified and got 3x over x parentheses 5x squared minus 4. And then I subbed in and got negative 3 divided by 4.
Right? Negative 3 over 4. All right. Anyone has any different answers? You see the trick so far, right? Sometimes we use the sine x over x when x approaches 0 to be 1. Sometimes we try to, try some strategy to cancel out some terms cause 0. Okay, great. Thank you. Now let's see next one. Okay. Emily, are you here yet? Jason? Karen?
Yeah, which one am I doing?
Oh, Karen, can you show next one?
Which one is that one? I don't remember.
Oh, which one we just did? 53, 54.
54? Okay.
We just did 53, right?
Okay, so I just took the 3 and the 5 out from the sine 3x sine 5x, right? and that turns into 15 sine squared x over x squared, and then that should be 15.
What?
What? I don't know.
I'm sorry, what you did?
We can, when we have sine 3x, we can take the 3 out, right? Like
Really?
factor out the 3? I thought you could do that.
No, Karen, no. Have you taken pre-calculus class?
I've taken both pre-calculus and calculus.
Okay, you cannot take out, this is the angle sine 3x, right? 3x is an angle.
Oh yeah, okay.
Right, you can never take out the 3.
That was probably from something else, I don't remember.
We want to use identity. Identity is saying sine 3x over 3x when x approaches 0 becomes 1. Okay, you know, guys, I have secret notes here, right? Because whenever I ask one to do questions, I basically give you a score. I hope, okay, so every time I pick someone to answer the question, basically I want to know where you are. Okay, where you are. And then basically I give you, I make my own notation to grade you, to give you a grade based on that. So be very cautious about my questions, all right? When I call on you, it's like a one-to-one quiz. All right. Let's see, next one. Let me see. Julia? Julia? And of course, when I call you, you're not answering me, that's absent notation. Hannah? H-N-I-N? Hannon?
Yeah.
Okay, please, let's try 54.
So for this one, I kind of like separate into sine 3x over x and sine 5x over x. And then I multiply 3 over 3 with sine 3x to get 3 times 5, and that equals to 15.
Okay, great. Yeah. So we need 3x and 5x for each. So we want to manufacture sine 3x over 3x, sine 5x over 5x. So we need 15x squared in the denominator. We don't have 15, so we multiply 15 over 15. So we're left with 15. Great. All right. So this one equals 15. So, all right. Anybody has any questions? All right, if not, let's talk about the new things. All right, today we're going to talk about continuity. So continuity means this. A function f is continuous at a value, right? It means the limit equals to the function value. Because in the past, we have seen certain situations, right? We have seen sometimes the limit exists, but the limit does not equal to the function value. But sometimes, of course, it's not continuous at the point. And sometimes the limit does not exist, which means the left limit and right limit do not agree. Then the limit when x approaches a certain point does not exist. Then of course the function cannot be continuous at the point. So function continuous, we use this as a definition for this book. Means the left limit agrees with the right limit, right? So on the left-hand side means the left limit agrees with the right limit. So we can talk about limit when x approaches a equals to the function value. Yeah, look at this graph, figure 1. For every point, this is one piece of string. So this function is one piece of string. At every point, at any point, the left limit and the right limit equals each other. Any point, pick any point. Left limit and right limit equals each other and also equal the function value. Right? So the picture is the definition. The definition, the picture of this definition is just this graph. The function shows as one piece of string, no break, no circle, right? No open circles. So we use this as a definition of function f is continuous. The left limit and right limit agrees with each other and also agrees with the function value. So three things agree with each other. Well, let's see this one. Well, the function from the, let's say from a negative infinity up to the point 1, right, when x equals to 1, is continuous. But at x value equals 1, we won't be able to talk about f1 because f of 1 is not there. So of course, the function is not continuous at x equals 1. It's not continuous at x equals to 1. Right? Because we don't see f of 1. Right? That's the open circle. Well, now from 1 up to 3, the function is continuous. Exclude 1, exclude 3. Right? So let me write here. So from negative infinity up to 1, you said, oh, I use open parentheses, right? Oops. So I want to write f of x is continuous at this interval. This interval is from negative infinity up to 1. Maybe I could use a double zero. Okay, this represents the infinity, right? Negative infinity up to 1 with open circle. That means 1 is excluded from this set. And the f is not continuous at 1. Then also I use open interval notation. F of x is also continuous at from 3, from 1, exclude 1, exclude 3, right? In the interval of 1 up to 3, exclude those 2 points. If I want to include those 2 points, I would use bracket. I would use bracket. But then f is not continuous at x equals to 3 because we don't have a limit at x equals 3, right? Limit of f of x at when x approaches 3 does not exist because the left limit equals to approximately, let's see, this is here, right? But right limit is here. So left limit and right limit do not agree. And the function value is this, agree with the left limit. So the limit does not exist at 3. So of course function is not continuous. Well, third one, then f is continuous at from 3, exclude 3, up to 5, exclude 5, open interval, right? So from here to here is continuous. It's a continuous string. But at 5, the limit exists, but the limit does not agree with the function value. So f of x is not continuous at x equals to 5. The limit exists, left limit and the right limit agree, but it does not agree with the function value. Function value is here.
Professor,
Yes.
is that is that notation correct for 3, 5? You meant to write them separately, right?
No, I mean interval. Interval means from 3 up to 5.
Oh, okay.
Interval notation.
Got it. Okay.
From value 3 up to 5.
I understand. I read it wrong. Thank you.
Okay, let's exclude 3, not including 3, not including 5. So this is the interval notation. If I want to include 3 and 5, I would use bracket. Use this notation. All right. Okay, great. Right, ask me any questions. Stop me, when you have any question. So then from 5 on, we say f is continuous from 5 up to past infinity. Right, I'm going to use a double zero representing infinity. All right, so the picture is here, picture from negative infinity up to 1, the function is continuous. But at 1, function is not continuous. Then from 1 up to 3, function is continuous. At 3, function is not continuous. Then from 3 to 5, function is continuous. At 5, function is not continuous. Then from 5 up to infinity, function is continuous. So this picture is a great picture. This covers 3 situations about limits, right? Limit does not exist at 3. The limit exists but does not agree with the function value does not exist. Limit exists, function value exists, but they do not agree. Any questions? Okay, let's keep going. Let's see example 2. Example 2 is asking, where are each of the following functions discontinuous? Right? Discontinuous. Discontinuous when the denominator equals 0, right? So the first one, well, let's see. Let's go through the book notation. So the A, B, C, D, we have 4 functions here. Let's say A. A is saying, notice f of 2 is not defined. We cannot talk about f of 2. Right? However, even we can simplify this. This one, once we simplify, we have x plus 1. Right? But the x plus 1 is a linear function. However, the function is defined this way. Because the function defined this way, even it can be simplified as a linear function, but still we make a circle. We make a circle when x equals to 2. So the graph of this will be a line with a circle when x equals to 2. Let me see if they graph this. Oh, here. Right? After we simplify this function, that becomes x plus 1. It's just this linear graph. But because the function is a rational function in the very beginning, that means 2 is not in the domain. So what do? We draw an open circle on the line when x equals to 2. So this is the graph of this function. And the second one, b is defined as piecewise function. So when x not equal to 0, it's defined as 1 over x squared. You can see it's this, right? 1 over x is on the first quadrant and third quadrant. 1 over x squared, it flips the third quadrant to second quadrant because every y value is positive. So this one. But then it says, if x equals 0, what do? We define f of 0 to be 1. So f of 0 from those two goes to infinity, right? Looks like it goes to infinity. But then the function defined f of 0 to be 1. So it's here. And of course, the function is not continuous, right? Because we see 3 parts. And the first one, the function is not continuous at 2 because this is a break. And this function is not continuous at x equals 0 because the left limit and the right limit goes to infinity, but the function value is 1. So the limit does not agree with the function value. So it's discontinuous at x equals 0. 3 is also defined as this. If x is not equal to 2, so defined as this. Now, if x equals to 2, it's defined to be 1. Well, let's see the graph. So when x is not equal to 2, it's this line with a break, right, with a circle here. And then when x equals to 2, define the function value to be 1. So f of 2 is 1. It's not continuous, right? Because the function value is here. But I would encourage you to think about this. What if I change the function a little bit? So sometimes when we do in life, what if I change this? What if I change this one to be when x equals to 2? Let me see this. So this is 1. This is approximately 3, right? Because x plus 1, 3. What if I change this one to be 3? Instead of 1. Right? If we change that to be 1, to be 3, let's see, someone is trying to answer this. Oh no, okay.
It will be limit and the function value agree.
Exactly, great. If I define this c, the function to be when x equals 2, the function value is 3, right? That means this solid dot will fill this empty dot, empty circle. So manually, we'll make a discontinuous function become continuous. That's what we do in life sometimes. All right, so the last one is a step function. This is seeing the floor. So take the integer part. So this notation means that. So basically, it's a step function. Between -1 to 0, we just take 0. Between 0 to 1, we just take 0. This is called a floor function. Imagine half, right? Imagine half here. Half, we just let the function to be 0. From 1 to 2, we let the function to be 1, because imagine 1.5. 1.5, we take the integer part. The integer part is 1. It's called floor function. From 2 to 3, think about 2.5. 2.5, we just take 2. So function equals 2. So floor function is a step function. A lot of times we use, yeah. So this is discontinuous, of course. So this definition is saying, so left continuous or right continuous. If the function value equals to the right limit, we call right continuous. If the function value equals the left limit, we call red continuous. So function, let's say this one, right? This one, everywhere the function is left continuous, right? Because right continuous. Because the red limit equals to the function value. The red limit equals to function value. So called red continuous. Okay, let's see this example. This example says show the function f of x equals 1 minus square root of 1 minus x squared is continuous on the interval. On the interval from -1 and 1 include. So we use this is using bracket. Bracket means the interval includes -1 value, includes 1 value. So what do? We take a limit. So take a limit of the function. The limit of a number, just a number. So limit of 1, just 1. And then we take a limit of this. So when x approaches a, we just substitute this x into a. So that becomes 1 minus square root of 1 minus a squared. And what is this? This equals to a when equals to f of a. I'm sorry, not f of a. This equals to f of a, right? F of a, just substitute x into a. Then, by definition, f is continuous a if a is from -1 in the interval of -1 and 1. So what do? Let's check the red limit. The red limit equals to, when we do the calculation, equals to 1, which is f of -1. Now what about the left limit? Left limit f of x equals, do the calculation equals to 1, which equals to f of 1. So we check the two endpoints. So conclusion, f is continuous. Well, the graph is just this, right? The graph from -1 to 1 is one piece of string. If we know this, what is this? This is the lower half circle of a unit circle with a third at 0, 1. So let's see this theorem. This theorem is that if f and g are continuous at a and c being constant, then the following functions are also continuous at a. All right. If it's continuous, it's a number. We can go through the limit to prove it. Any polynomial, like linear function, quadratic function, cubic function, or nth degree polynomial function is continuous at all real numbers. All real numbers. This uses this doubled R to represent from -infinity up to infinity. So this is the interval notation. Interval notation. Why we do not use bracket? Because infinity is not idea. It's a concept. It's an idea. It's not a number. So we use open interval. Any rational function is continuous whenever it's defined. All right. Whenever the denominator is not 0. Let's see this one, example 5. Find the limit x approaches -2 for this rational function. Well, let's see. If we plug in x equals -2, well, that causes the denominator to be 0. -3 times -2, that's +6. 5 plus 6, that's not 0. So we can just go ahead. And evaluate. When we evaluate, that's -1/11, which is f of -2, right? Because -2 is in the domain of this rational function. So we have no problem to plug in. That means for this rational function, this rational function is continuous at x equals to -2. All right. So -2 is in the domain. So that's one way to see it. Or we could see we call the function f of x. Okay, f of x is continuous at x equals to -2. It means the same thing. All right, so those two ideas means the same thing. So -2 is in the domain of this function, or this function is continuous at x equals to -2. So it equals the limit. It equals the limit. Tangent function, right? Tangent function, we say it discontinuous at pi over 2, pi over negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, you know, all those up pi's over 2. Tangent discontinuous at those points. Let's see this one. This theorem is saying the following types of functions are continuous at every number in their domain. Polynomials, rational functions, root functions, trigonometry functions, right? You know, the domain of this function A is every real number, which means the left limit and right limit and the function value coincides. And this one, only when x equals to 1 or -1, it discontinues. At all other points, function continuous. And this one, let's see this one. Square root of x means x cannot be negative, right? X cannot be negative. X only defined when x is non-negative. And this part of the function is x cannot be 1. If 1 will cause 0 in the denominator. And this piece is saying x can be any number, right? This even is a rational function, but x squared will never be -1. So this piece of function says domain is every real number. This piece says domain is everything but 1. This is saying domain is all non-negative numbers from 0 up. So we just put all those together. Put all those together, give a notation. See, f is continuous. We could use one way. We could use this notation. This is h. H is continuous from 0 up to 1. You're including 0, exclude 1. Uni, and means uni. Uni exclude 1 up to infinity. This is interval notation, right? Interval notation. So that's for C. C we have 3 pieces, so we have to analyze each piece. Then find the intersection, the intersection domain, which becomes the domain of the function h. Okay, any questions?
Can you share or restate that last part for C? It was so I got that the square root of x has to be it translates to everything 0 up, and then the second part is that 1 is not in the domain, and then what is the third part for the x squared plus 1?
Okay, will the denominator ever be 0?
No.
That's my question to you.
No.
No, that means all real numbers, right?
Okay.
Okay. All right, anybody else has any question? Okay, let's see this one. This one is saying if f is continuous at b and the limit of g, another function equals to b, then we can factor out that f of g of x equals to f of b. In other words, limit of f, composition of functions, we can factor out f. All right, to do this, we'll see examples. This is kind of difficult to understand, but when we see examples, it will make sense. And this theorem is saying if g is continuous at a and f is continuous at g of a, then the composition functions is continuous at a. All right, this is kind of dry, but when we see examples, we will understand. Let's see example 7. So hx equals sine x squared. And we can think h of x as, composition of two functions as f of g of x, right? G is a square, right? G takes x as square, and f takes an input, assigns a sign to it. So f is a sine x. G is x squared. Okay, this is a super important idea. Make sure you understand the composition of functions, because when you go further with calculus classes, it becomes such important skill to have. So in this case, well, let's write out on the side. So we say h of x equals to f of g of x, composition of two functions. How do we see that? Let's plug in h of x equals to f of, what's g of x? G of x is x squared, right? What is f of x? F of x, assign the input sine x squared, right? So the idea is in this line, all right? H of g of x, h becomes f of g of x, f takes the g of x as input. G of x is x squared, so f take x squared as input. Then f itself is sine, so sine x squared. That's the process. So x squared is a polynomial. So that means the domain of x is every real number. And for f sine x squared, right? Sine also takes all real numbers. So that means h, the domain of h is all real numbers. Well, let's see b. B, we have this 1 over square root of x squared plus 7 minus 4. So let's see. We can write this as, looks like a complicated. We can write f of x as f of g of h of k. Let's write on the side. So big F of x equals to f of g of h of k of x. Well, each one is defined as here. So f is defined as 1 over x. Give me the input, I'm going to take an inverse, right? 1 over x. G of x is saying, give me the input, I'm going to subtract 4 with it. We'll see from this part, right? You see the first part, f is 1 over something, big fat x. Then g is, you hand me something, I'm going to subtract 4 with it. H is saying, give me something, I'm going to square it, square root of it. I'm going to put square root of it. And the k of x is saying, give me something, I'm going to square it plus 7. So say 4 layers. So each one is defined as this. Let's just plug in f of x equals to f of g of h. Well, h takes a kx as input. Kx is x squared plus 7.
Professor?
Yeah.
Is it possible for like problems like this that we can create a table?
Well, you can you can do that. You can do that. Right. But for myself, I like to see the layers. I see first 1 over something, right? Then I see something minus 4. Then I see something square root. Then I see something square plus 7. That's how I see it. Just like this. Just like this. So very inner layer is k. What does k do? K said, give me input, I'm going to square it, then plus 7. Then the second layer is square root. You give me something, I'm going to square root. Then third layer is, if you give me something, I'm going to subtract 4. Then last one, if you give me something, I'm going to do 1 over it. There's not only one way, all right? For compositional functions, there are many ways to compose. You can write this one totally in different ways.
Okay,
It's
but
not only one way.
But
It's
for,
not unique.
I understand, but for this one, can we do it like both ways, just for like example?
Oh, for me to do a table?
I don't know if you can do it with the.
No, I don't know how to do with the table. I don't know what's your idea, but you can try yourself.
It's similar to like the difference quotient, but I mean this table would be bigger.
You know, you can try when you have time, all right?
Okay.
Yeah. You can try. I'm just telling you, you know, different people, the different ways to decompose, to make a composition functions. All right? You can make 2 layers, you can make 3 layers. You can make it like this one, you can make 4 layers. All right. Let's see this one. Let's follow the book. All right. So now we have f of g of h. No, h. All right. H takes x squared plus 7 as the input. But what does h do? H is square root of the input, right? So square root of the input. The input is x squared plus 7. Then next layer. So f of x equals to f of g. Now g takes the square root of x squared plus 7 input, but how is g defined? G is defined as you give me something, give me the input, I'm going to subtract 4. So g takes square root of x squared plus 7, then minus 4 to it. So we just go inside out. So k of x is defined x squared plus 7. We substitute k of x. Then h is defined as the square root of the input. So we just square root of the input. And g is defined minus 4 with the input. So we just take the input minus 4. Then now last layer, big F, small f. So f of x. What does f do? F take the inverse of the input. So that just becomes the inverse 1 over square root of x squared plus 7 minus 4. Okay, we're going back to the function. But there are different ways of doing this. Okay, you can, this is to show you one way how we see the function is a composition of functions. All right. Okay, any questions? Right, it's inside out. Composition functions inside out. You see the first one, right? F takes a G as the input. Well, if going back here, F takes a G as the input. G takes H as the input. H takes a K of X as the input. So this is the definition of composition functions. It's not from right or to left or from left to right. It's the input, right? Let's see H of X. H of X, X is the input. But when we decompose f of g of x, g of x becomes input of f. Make sense? In this case, it's also layers by layers. K takes x as the input. H takes the k function as the input. G takes H function as input. F takes a G function as input. All right. So this is the idea of composition of functions. You should have learned this in pre-calculus. Anyway, this is such a big idea. If you feel yourself is weak on this, make sure you read a couple of times. Make sure you give yourself a couple of functions you decompose as composition of functions. All right. And later on, we're going to talk about chain rule. When we differentiate a function, all right, something called a chain rule, you have to understand this composition of functions. And when we later on talk about integrations, also chain rule. So if you are weak on this composition of functions ideas, make sure spend some time to see these examples, to try some questions. Okay, let's see example 8. Example 8 is saying showing that there is a root of this equation. So this is a polynomial, right? Polynomial degree 3 is difficult to solve for the root. Usually it's difficult to solve for the root, but this one we could do it. If we factor this, so one way we could do this, we can factor this. Then when we factor this, we factor out the 2x squared. When we factor out 2x squared, we have 2x squared. We have 2x minus. Oh no, we won't be able to do that. Even with factor, they don't have common factors. But sometimes maybe we're lucky, we can factor out. We can use a property of zero property to solve. But a lot of times we don't have the luck. This one we want to show this equation has a root between 1 and 2. So we won't be able to tell what the root exactly is, but we can tell there is a root between 1 and 2. So how do we do that? Well, let's try to evaluate f of 1. So at the point 1, f of 1, when we evaluate this, we get -1, right? -1 is under x-axis, right? -1 is under x-axis. So the function is under x-axis. And evaluate f of 2. f of 2 equals 12, which is positive, is above x-axis. And of course, this is a polynomial, right? This is a polynomial. This polynomial, if we think of this as a function of polynomial function, f of x, right, equals to 0. So we just take it as a function. Function equals to 0, right? This is one of the equations of this function. And because polynomial functions is continuous on all real numbers, so that means this polynomial is one piece of string. It's one piece of string. So it has to pass the x-axis. Then we get a point right here. That's a root. So function f equals 0 at this point. So that's how we use this strategy. Well, this actually, I think you have done this in pre-calculus class. Right? Whenever we want to show there's a root, the root means there's a point the function cross x-axis. Cross x-axis. So we want to find a value being negative, a value being positive, value under x-axis, and value above x-axis. Because the function is continuous in the interval, so it has to be a root. All right. I'm going to, let's see. All right. So of course you have homework, but this one I'm assigning you for. So next class we're going to start to review those questions. Okay, number 4. Number 4. Okay, number 12. And number 16. All right, I'm leaving you these 3, 4, 12, 16. So we will review. I'm going to call people 4, 12, 16. Call someone to show, all right? Okay, so I leave these 3 exercises for you. Number 4, number 12, number 16. Anyone has any questions? If not, we finish now, okay? If anyone has any questions, you can stay, ask me questions. All right, now see you. So today is Thursday. I'll see you next Monday then.
Professor,
Yes.
someone asked a question in the group chat.
Oh, I see. George, do we have schedule for exam dates and stuff yet? Not yet. Not yet. So basically, at this moment, make sure this work I assigned to you, because I don't have a quiz for this. And make sure you do these questions. Make sure when I call your name, you're ready to answer the question. All right? You're ready to answer the question. Remember how? Let's see the syllabus. The syllabus is saying. Let's see the grading policy. Okay, see the grading policy, 10% presentation, 20% homework, 30% quizzes. Okay, the quizzes, the idea of quizzes is not as in the past anymore. It's not, it's in the class, it's easy to do quiz. But for now, it's not easy to do, the traditional quiz anymore. So how do I give you this 30% quiz score? Is by assigning you work, like I did last time and this time. This time I leave you 3, 2, 14, 16 to try. And next class, I'll call people. Okay, that's your quiz score. That's 30% of your grades. If you're able to show me, if you're able to explain, how you did, then you get the right answer. You get a full score basically. So I will mark your name down. I will give you grades under your name. All right. So make sure I assign you this work. You can do it, so you don't miss these grades. All right, only 40%. You see, 40% for final. I don't really know how to do final yet. Okay, hold on a second. No. This is not 250. This is 150. This is 150, right? Because for final is 40%. Final is 40%. If in the end, I see most of us doing fantastic job, so which means, you do your homework, you do those quiz under the course, we may not even have to have a final. All right. So just please try to catch up with the class. So from today, I could see, a couple of students are not able to catch up with us yet. So please make sure you're in the right class. Okay, you have passed the pre-calculus class. You're supposed to know all of these functions. For telling me sine 3x is equals to 3 sine x, that's totally wrong. Basically that piece of information is telling me you are not ready for this class. Maybe you should consider to go back to pre-calculus class. All right. So at this moment, so please try to catch up with this class. If this is truly difficult for you, you may think to go back to study pre-calculus class. That's a super important class, which is 125. All right. To be in this class, you have to be ready for it. I'm telling you, this is sad news. Every semester, there are students that fail this class. The pattern is these students do not do their homework, or maybe do not do their homework on their own. They're not able to catch up with the class. They're not able to answer my questions. They get poor grades on exams. But right now, because everything's online, it's very difficult to do exams, right? So this is one way.
Professor,
Yes.
what about the quizzes and the homeworks on the Lumini?
Yeah, that's homework, right? Yeah.
So those quizzes count as well, right?
Those quizzes count as well. You don't have to do all of them. Just do one of them after each section.
Okay.
All right. Just more important for me to know you. All right, because we're not in a physical classroom. So show me you are understanding me. If at any time I confuse you, you have every right to stop me from going further. Ask me to clear up for you. Okay, please. All right, any questions? Yes.
Professor, I have a question. So you're saying that you're keeping track that you'll call on us for quiz grades. Have you already started that before, or is Monday the first official day that you're keeping track?
We only do the 2 days, right? Last time and this time. Actually, last time notation I erased. I was thinking that's the first time. I started from today.
So today is the first day that you're
Today is the
putting
first
quiz-
day I make notations. Yes.
Okay, thank you.
I mark these notations under your name. So make sure, right? Just make sure you're trying to understand me. If I ever confuse you, I'm sure I confuse you a lot of times. Stop me and make me explain. All right, I see you next Monday. Okay, have a good day. I have to prepare to go to next class.